Hello, I'm Mrs. J, and today we're going to cover 14.1. And the first thing with 14.1, you're looking at the absolute highest, because we talked about relative maximum, and this is absolute maximum. So the first thing to find absolute maximum, you find your critical numbers. On the interval So when you're looking for the maximum, you're usually given endpoints and you're including the endpoints. When you're finding the critical numbers, you're finding the critical numbers that are between those endpoints. You don't need to include endpoints because you already are here. Then you evaluate the function at the critical numbers and A and B. So you do your endpoints and your critical numbers. Why that keeps doing that. And lastly, by evaluating, that just means you plug it into the original function or the one before the derivative, and the largest y value is max, absolute max. And smallest y value is the absolute min. Okay, let's try one. So we want to find the interval between -5 and 5 for this function. And it's f of x equals 4x to the 4th. Oh, come on. There you go. 4x to the 4th minus 32x squared minus 7 between -5 and 6. When it says absolute extrema, that means they want the absolute max and the absolute min. So the first thing we want to do is find our critical numbers. To find the critical numbers, take the derivative, set it equal to 0. So when we take the derivative, we get 4x cubed minus 64x minus 7. Yeah. Oops, not minus 7. 7 drops out because it's a constant, it's 0. Then we set that equal to 0. Notice we can factor a 4x out, and we're left with x squared minus 16. And x squared minus 16 is the difference of squares. So set each of these equal to 0. Our critical numbers are x equals 0, x equals 4, and x equals a -4. So these are critical numbers. Now we want the critical numbers between these. So when you're finding your maximum, you use your -5 and your 6, these endpoints. And then you use any of these that fall between there. And all of them do this time. So we have a -4, a 0, and 4. So between since all the critical numbers were between -5 and 6, we use all of them. If maybe we only went to on -1, then the -4 wouldn't have been included. Okay, let's graph it. When you're graphing, you want to look at where your derivative is and take the one before. And I already put it in here. It's the first one. So you plug it into y equals, go to your window, -10, 10, -275, and 275, and you hit graph. We know that there should be 3 bends in the graph. 1, 2, 3, because we had 3 critical numbers. So it looks like that. Our critical number was at 0, 4, and -4. Now once you have it graphed, you want to plug these in. Now I graphed it so it's under y equals. I can go to my table and plug it in. I'm going to delete these. We want -5, -4, 0, 4, and 6. So there's the values. Now the highest value is the absolute max, the lowest is the absolute min. So this was our highest, so we have an absolute max of 137 at 6. And then notice the lowest, there's 2 of them. So we have an absolute min of -263 at -4 and 4. Let's try another one. So here we have P of X, and we want to find the maximum weekly profit when X units of auto parts are sold, and X has to be between 50 and 150. We need to find the critical numbers. So the first thing we need to do is take the derivative and set it equal to 0. We want the critical numbers that are between 50 and 150. So take the derivative. Put it here. -0.06 x squared plus 600. Setting that equal to 0. Dividing by the decimal. We get 10,000. Taking the square root, we get plus or minus 100. So our critical numbers are 100 and -100. So for our table, our endpoints are 50 and 150. Well, -100 isn't in that interval, so we only use the 100. So under y equals this one, I put in the profit function, change our window, -200, 200, -6, 4 0, 60,000, 1, 2, 3, 4. and 20,000. And graph it. There we go. About like that. Increasing and decreasing change at 2 spots, and we had 2 critical numbers. This would be at -100 and 100. To find these values, go to our table. We plug in 50. Delete these. 50, 100, and 150. And there's our Y values. We wanted the maximum, so it's this one. There is a maximum weekly profit of, X was units of auto parts, and it doesn't say that it wasn't dollars, so you would assume dollars. So a weekly profit of $20,000 for 100 units of auto parts. So if they sell 100 units of the auto part, they'll hit their weekly maximum profit of $20,000. Try one more. Find the maximum profit, or find the minimum, sorry, minimum average cost. We have the cost function, minimum average. This. Now, sometimes when you're just dividing by x, and we need to find the critical numbers, so we have to take the derivative and set it equal to 0, it's easier to divide the x into each of them. So if we divide the x into here, we have 81x. Dividing it here, we just have 17. And here, we can bring the x up so that we have 324x to the -1. This is easier to take the derivative of and to simplify later. So I would rewrite it. But if you use this, it's fine also. So when we take the derivative, we get 81. This would be a negative 324x to the -2. We want to set that equal to 0. I'm going to add the 324 to the other side. At the same time, I'm going to move this back down to the denominator, because then I can multiply it to the other side. And then divide by the 81. And take the square root. I don't think 324 has a square root. Oh, it does. It's 18. So we have 18 over 9 plus or minus 2. So our two critical numbers are a positive and a -2. Let's look at the graph next. So I put in the average because, remember, go to where your derivative is and use the one before, because we're interested in the average cost function, not the cost function. So this is the one we want to graph. You can either plug this in or this one, either one, the one before the derivative. And the window, -25, 25, -1,000, and 1,000. Graph. over here and here. And this is our -2 and 2. Where we can see it. Okay, look in the first one. There's two parts. The first one wants us to find the minimum average cost between 1 and 10. So 1 and 10 are our endpoints. And 2, one of our critical numbers, the +2, is between there. So we want to check 1, 2, and 10. And we plug those in. Go to our table, delete what was there, and put 1, 2, and 10. 1, we have 422, 341, and 859.4. We want minimum average cost. So what this is telling us is if we buy 1, then it's $422. If we buy 2, it's $341 each. If we buy 10, it's $859 each. So this is better. $341. Now, what if for some reason they want to ship between 10 and 20 instead? Well, 10 and 20 are our endpoints. When we go to our critical values, we don't have any critical values between 10 and 20. So we only use 10 and 20. We found 10. If we buy 10 of them, they're $859 each. How about 20? Plug 20 in. Oh, that's bright. Plugging in 20, we get $1,653. So if we buy 20 each, they're costing $1,600 each. For the minimum, then it would be $859.40. So that's everything for 14.1.